Hi, everybody. Today, for the Power Talk, we'll talk about the OpenStudio Coalition and some of the updates to the software, the organization, and some market opportunities. So with that, here's some context. So with the OpenStudio application, as many of you might know, the DOE and national labs no longer support the user interface, but do support the underlying physics engine of Energy Plus and some of the ancillary products like the building component library, parametric analysis tool, and the software development kit. So to that end, a few of us have teamed up. So the Energy Coalition, based in California, Performance Systems Development, based in New York, VEIC in Vermont, and FUBEM, and a couple others have partnered to maintain the UI in SketchUp as the SDK has subsequent releases. And so what we really want to try and do is not only support the software, but support the BEM industry along with all the partners involved in it. And we also want to find our lane and play complementary roles with existing software that's out there. And so just for a little bit more context, the strength of the OpenStudio system application is that it's open source, it's transparent, people can download it, inspect the source code, and contribute back to it. But most importantly, it supports an entire ecosystem that dovetails with other federal research initiatives, ancillary services like the building component library and the parametric analysis tool. And naturally, it supports Energy Plus as that's funded and updated. Currently, we have over 70,000 users in 70 countries, which is pretty interesting for us. And again, it's a free and low cost software, and that's really unique to this. And we have to really charge ahead with, how that supports the BEM industry in concert with other commercialized products. So you can see that within this ecosystem, it's like a Swiss Army knife that it does a whole lot of things around policy analysis and retrofit design and code analysis and so on and so forth. So in the future, what we're looking at is the market is bigger than one software. And as an industry, we need to keep up with those trends. And so where is the market headed? Well, if we think about it in the context of what can we do with the available money that's out there, NASA, for example, their fiscal year 2020 budget, $22.6 billion. They sent the Mars rover out there, right? The Moon to Mars program, Gateway Lunar Orbit programs. California retail energy sales, not a direct comparison, but the order of magnitude in what people spend on energy in California alone, $45 billion. What have we done with that? And more importantly, are we unlocking the potential within the energy sector, which is a huge, huge market? And so what we can look at, currently what's happening with OpenStudio Energy Plus is the TRM in New York is being updated to include some of these new tools that are compatible with federal software. The CPUC is really moving away from DOE2. We see heat pump calculators being really in demand. ASHRAE 229 is really pushing the envelope in some of these things. 90.1 Appendix G in the PRM is a huge opportunity. And the building component library updates are really extending the power of what we can do with extensible tools, and ideally across all tools so that we have a common denominator between all of us in the industry. So some things that we've been involved in that seem relevant to this talk and where the market could be heading is how do we really analyze distributed energy resources and communicate that to the supply side people in a way that shows value in understanding end uses, appliances, and how do you build on top of that for intelligent load control? It's an emerging topic within the realm of demand flexibility, which also goes into the grid interactive efficient buildings roadmap and analysis that's needed as the line is blurred between energy efficiency, demand response, and then by extension, grid operations with generation and storage, whether they be on site or in your community. And one level above that is how are utilities, distribution system operators, and others thinking about how to manage those assets that are behind the meter. Most often than not, they only care about what the meter shows, but there's definite value not only for the market, for the grid, but also huge opportunities for revenue streams in being a little bit more sophisticated in how we understand, dispatch, and manage assets behind the meter that are controllable and communicate those back up to a grid operator. Also, with the advent of large scale analysis, how can we take all that information and fold it back into policy updates that have traditionally been done outside of this context from a really truly bottom up approach? And then a really exciting part is virtual power plants and transactive energy networks, in terms of how can people share, use, sell, and buy energy in ways that have not been done before and that are currently prohibited by regulation. And the way to prove that out is, one, to actually do it, and two, maybe a step before that, is to simulate it through what we're doing in the industry here in CalBEM. So what do we need? Some rule sets for operational rule sets, right? How do we standardize or have the flexibility to understand how these transactive markets can work? Is there a standardized way that we can, just like the OpenEI rate database, ingest demand flexibility or demand response programs, dispatch signals, frequencies, durations, and standardize those? Also, how do we calibrate devices for load impact protocols and demand response settlements? How do we look at grid awareness and what a device or a home or site or premise needs to do to interact with the grid? There's automated identification, retrocommissioning, really interesting thing that some of the national labs are working on, where devices are recognized by IEEE standards and other standards that you can then feed back into your models for calibration. Part of that's IEEE 2030.5. And then just more robust analysis and modeling DERs. And so if we can kind of tie all these together, this really opens up an entirely new channel for BEM in California, and hopefully can rapidly accelerate how we deploy, quantify, fund, finance, and show value to the end users in terms of what we can do through BEM, and then go through that and actually put it on the ground and serve our role as modelers in the industry. So a lot of exciting stuff to come. We'll see what happens. And that is the end of the presentation. So thank you very much and have a good rest of the conference.